So two very simple functions on the screen here now. We've got a linear function and a quadratic. Let's restrict the domains here. I'm only interested in the area between the two curves. Okay, now that we've done that, let's move ourselves into 3 dimensions. And then let's take that linear curve and rotate it around the x-axis. Rotating, 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 and we get a cone. Okay, we can also take our other curve, our parabola, and rotate that around the x-axis as well. That's the purple thing you're looking at. All right, let's rotate the whole thing together. Okay, that's what this video is about. We're going to be finding the volume, not of inside the blue thing, not inside the purple thing, but between the blue and the purple. If you were making this bowl, how much material you would need. So this is what we were just looking at, just drawn by hand. Now, what we're trying to do is this bit here, taking that bit and rotating it around the x-axis. Now, you probably don't need this video. You can probably already figure out how you should do this. If you find the volume of the blue thing rotated around the x-axis, and then you find the volume of the pink thing rotated around the x-axis, and you subtract one from the other, you'll have that pink bit in the middle. Now, I've picked us 2 really easy functions here. F of x equals x, just a straight line, 45-degree angle, and g of x equals 3x minus x squared. All right, let's find the volume of both of those at the same time. In simplest terms, the volume between these two, when we rotate them around the x-axis, will be equal to the volume of the top function minus the volume of the bottom function. That feels familiar from finding areas between curves. All right, how do we find the volume of the top? It's pi times the integral between b and a of g of x all squared with respect to x. G of x is our pink function here. What about the bottom function here? How do we find the volume rotated around that? Same deal, pi times the integral between b and a of f of x squared with respect to x. Now, we have 2 terms, and you can see they have pi in common. So we can bring pi out on the outside. So let's close up that final bracket here. We have pi times all of this. The integral between b and a of g of x squared minus the integral between b and a of f of x squared with respect to x. Now, if that's being integrated between b and a, and that's being integrated between b and a, we can put them both as a single integral between b and a. And this formula right here is our golden nugget. This formula here, if we want to find the volume between 2 functions rotated around the x-axis, this is it. Pi times the integral between b and a of one of the functions squared, the top one, minus the other function, the bottom one, squared. Okay, now some people might want to do something a bit silly. This is wrong. This is wrong. What I've done is the integral between b and a of g of x minus f of x all squared. Because that's squared and that's squared, so why shouldn't that be squared? But remember, the difference of 2 squares does not equal a plus b squared. A lot of year 9s make that mistake. So this is garbage and this is garbage. Garbage, don't do it, that. So now that that's out of the way, let's turn our hand to the specific question that we had. The volume here will be the integral between b and a. Now, this intersection point, I've already calculated it, it's 2, and this point is 0. Let's stop for a second. This specific question, I've decided to find the volume between this point and this point, where the 2 things intersect. But that was just a decision when I created this question. It doesn't have to be that way. You might get asked to find when you rotate that around there, when this is the number 1 and this is like 1.5. You might get asked to rotate between here and here, between 0 and 1. You might get asked to rotate the area enclosed, which is the question I'm doing here. Don't think that you always have to rotate the area enclosed. It's just this particular question that I'm doing it in. So continuing, we need g of x, the top one here. So that's going to be 3x minus x squared. But don't forget, all squared. That's the key when it's these solids of revolution. And minus f of x squared. Now f of x is just x. But f of x squared is x squared with respect to x. All right, we're going to have to expand that bracket, but not first before remembering that I've stuffed up and we need that pi right there. Now let's expand. All right, so that's that bracket expanded there. The negative x squared is brought down from here, and we can tidy that up. 9x squared minus x squared is 8x squared. Now, this is the integral of a polynomial, right? Forget this pi out the front here. All of us should be able to find the integral of a polynomial by now if you're looking at something like this. And the integral of that polynomial is just 56 on 15. And don't forget the pi here. So it's 56 on 15 times pi. Let's write it like that. Okay, what is that? That is units cubed. And that's approximately 11.73 units cubed. And again, this question is a great one for asking you to check your reasonableness. How do you guess that that volume is approximately 11.73 units cubed? You can sort of find out what the volume of a rectangle would be. You can find out what the volume of a cone is without doing volumes of solids of revolution. There's a lot of ways that you can guesstimate, well, that's the right answer. I'm going to tell you it's the right answer. I know it's the right answer. That's how you do volumes of solids of revolution between two curves.